Let's look at an example of compositions of functions where we're given two functions asked to find a composition as well as its domain. So the question here is, consider the functions below. F of x equals x divided by x minus 4, and g of x is equal to 7 divided by x. And part A of our question says, find f composed with g of x and its domain. F composed with g is defined as f of g of x, which is further defined as f of 7 divided by x, which from there we replace every x in f with 7 over x, and would have 7 divided by x all divided by 7 divided by x minus 4. Now let's pause and think about the domain implications. First of all, the very first place your value x has to be substituted into is the function g. Since g has a denominator of x, we see that x can't be 0. Secondly, 7 over x has to be substituted into f. F has a denominator of x minus 4, so when we substitute, we see that 7 divided by x minus 4 can't be 0. This leads us to 7 divided by x cannot be positive 4. So 7 cannot be 4 times x. So 7/4 cannot be the value of x. So this would mean that ultimately the domain of the composition would be the set of all reals except 0 and 7/4. And we could choose how we wanted to write that, whether interval notation or whether we had a multiple choice question and made a list of values. If it's an interval notation, then we would have minus infinity to 0, union 0 to 7/4, union 7/4 to infinity. Okay? The part B of the question is to find g composed with f of x and evaluate its domain as well. G composed with f is defined as g of f of x. So I'm looking at g of what? Well, I'll go back and, like I did before, find what I'm substituting. So I'm looking at substituting every x in g with f of x, which is x minus 4. Or excuse me, x divided by x minus 4. And in turn, g's formula is 7 divided by its input value. So we would have 7 divided by x over x minus 4. Now, WebAssign doesn't really care if you simplify that or not. So as far as getting the answer for the composite function, you certainly can leave it this way. Now, as far as the domain is concerned, go back and look at incremental steps. The very first place x goes is into f. We see f has a denominator, and so therefore x minus 4 can't be 0. So our conclusion is, first step, x can't be 4. Secondly, g of x also had a denominator, and we've replaced the denominator of g with the function f of x, so we cannot have x divided by x minus 4 equal to 0 either, which leads us to the statement that if we cross multiply, that x can't be 0. So the domain of g composed with f is the set of all reals except 0 and 4, which in interval notation would be minus infinity to 0, union 0 to 4, union 4 to infinity. Okay, but again, to recap, you work your way inside out, and particularly with the domain, I think it's helpful to not simplify so that you can see clearly what exclusions you might have to make.